So it seems that altogether we have 5 people online so far. 12, 13, 14, 15. 15 of, I believe, 26 people attending. So those are not very good attendance numbers. I think I'm gonna have to do something about that in due time. So be prepared. Okay, so just a heads up, there is a homework assignment due tonight in my stat lab. And this homework, Intro to Statistics, I did recommend that you start on the first half of it now, and I was going to talk about sampling, which really is not very difficult. They're mainly multiple choice. Which sampling method does the situation describe? And I'm going to talk about those types of questions momentarily. Also, the section on qualitative data is going to be due Wednesday as well. We're going to go through qualitative data today. And there's only 8 questions on it. So just keep that in mind. Besides for that, does anyone have any questions for me before we get started? If not, let's go ahead and do exactly that. So we're going to pick up where we left off on sampling methods. And with sampling methods, I'm going to kind of go through it again, just to emphasize it a little bit more. So remember, in this class, instead of studying or doing a statistical survey on a population, we tend to want to pick a subset of that population called a sample because, well, sometimes it may be too long to figure out all the people in a population. Or maybe we want to save some money by only picking a certain number of people, a certain number of accessible people that may give their characteristics in general, might provide some general outlook for the population. So we can make some sort of observation, some sort of claim. This is used a lot in government where they figure out how to distribute federal funds. They want to see how many people are in certain regions, what their incomes are, what their genders and nationalities. They want to figure out all these things to figure out various programs and ways to help those areas through federal funding. And so one question is, how do you obtain a sample? And obtaining a sample isn't just as easy as, all right, go find 20 people from these 100 people and study them. Because sampling tends to have an inherent issue with bias. And you may think that if you go to a grocery store and you ask 20 random people in the store at one time what their shopping habits are like in order to figure out what inventory to purchase, those 20 people in the store at that one time may not be, even though you picked them out randomly, that still might not be a random sample. A truly random sample would be any person who goes to that store has an equal likely chance of being picked, even if they go to the store once a year. It seems a little weird, but if you want to be completely non-biased, so if you ask the first 100 people that leave a store what their shopping habits are, generally people who go to the store earlier in the day tend to be older and would probably get basic things like eggs, milk, and bread. As for people who go later, they tend to be a little bit of the middle-aged, the younger side, or at least my experience when I go to Albertsons every now and again. So even that would be biased. And so from random sampling, that kind of streamlines very nicely into simple random sampling. It's kind of the same thing, but just refined a little bit more. The way you take a smaller population with a size little n, in fact, I'll just go ahead and highlight this. So simple random sampling. So the sample has size n, and the population has size big N. And this is, as I said before, every possible sample has an equal likely chance of occurring. So again, I think I gave an example last time in class where I said you wanted to judge or you wanted to survey how often the citizens of Hammond, Louisiana are outside during the day. And so you go and survey the first 20 people you find on the street. What you're doing, though, is you're finding a biased sample because you're finding people that are already outside instead of including the ones that are inside and may not even be outside in the first place to be a part of your study. So that would already be biased. Perhaps mixing up the names. If you have a list of names and you mix them up and you send snail mail to each random person, like 20 of 100 citizens of Hammond, that would be a more that would be a better example of randomized sampling, taking a list, mixing up the list and choosing 5 from there without knowing any of their characteristics whatsoever. Now, normally this is done through technology. We're not going to talk about this too much in this section, but if you're interested, technology uses a thing called a seed, and the seed is this way, it takes this random number and then it's able to randomly pick from that seed a random number in some interval you give and how many numbers to pick. Basically, the technology you use is probably going to be the most unbiased thing you can use because unless you give it some sort of extra information, it really just has no idea who these people are and what they do. But there's other sorts of sampling other than just picking them out just randomly from a population. There's stratified sampling. And stratified sampling is when you take a larger population and you split it into these smaller, non-overlapping groups called strata, and then you perform a simple random sample on each one of those smaller groups. This is normally done. So this is normally done if you wanted to. So let's say some politician wanted to determine Texans' views on a certain policy passed, and they said rank from not favorable to favorable what your opinion on this policy is. If you do that for every person, let's see, I believe in the last election, the state of Texas leaned more red, so you might not get a completely diverse collection of opinions. So that's the strata in this case. The groups would be the political affiliations. You would want to do interview Republicans individually, Democrats individually, independents individually, and then see from each one of those individual parties how they all individually think. So that's stratified sampling. So you take a population, you split it into these smaller groups, and then you apply random sampling to each one of those groups. There's also systematic sampling. So systematic sampling, this is best used when you don't know how many people are in your population. So you select a random person, and then every kth person, so every third person or every third object that comes by, then you interview them next, and then every third person, on and on and on. And so I have an example here right below. The number of customers that may attend a store, you don't know how many people are going to attend that day. So what you do is you apply systematic sampling. And so starting with the third customer that leaves the store, you interview every 5th customer after that. So the third customer would be first, and then every 5th customer, so 4, 5, 6, 7, 8. And the 8th customer, and the 9, 10, 11, 12, 13, and you keep going in that regard. So you're not picking a consecutive group of people. You're spacing it out a little bit, hopefully to get a more diverse collection of characteristics of your sample set. We have a cluster sample as well. Cluster sample, this one almost sounds the same as the stratified one, because clusters, you may think this is also the strata mentioned in the stratified sample. But what cluster does is it selects all the individuals. So the randomization here is the group, and then you interview every person within that group. So it's not the individuals being randomly selected, it's the groups that are being randomly selected. And a good example of this, so the book had a good example of this. If you want to, let's go back to Hammond. You want to figure out some characteristic of the people in Hammond. The clusters could be residential blocks. And then you're randomly choosing maybe 5 blocks in Hammond. And then you're going to interview every person on those blocks that you chose. So it's in cluster sampling, it's the groups that are randomized, and then you interview every person within that group. Stratified is you interview all the groups, but you randomly select the people within the groups. So slightly different. And then there's a convenience sample, which is the worst form of sampling, which is probably the one that we would all naively do if we weren't aware of its inherent bias. Any time in which individuals are easily obtained and not based on randomness, you're inherently going to introduce bias. This is sort of the flaw with, say, going to the Breezeway in Southeastern and surveying a bunch of people. Those people that you survey on a particular day, if you just survey everybody, they might tend to inherently share some sort of characteristic which may bias your understanding of Southeastern as a whole. What about students that don't attend school? What about students that don't attend school on those days? What about students who go to school at night? You're sort of skipping out on a certain demographic, and maybe there's a chance that it might not be biased. Maybe it's a truly random sample, but generally in statistics, this is not a favorable mode of collecting samples for a population. And so that's 5 examples of sampling, ultimately. Simple random sampling, stratified sampling, systematic, cluster, and convenience. And there's a few questions in the homework that ask you to hear a sampling situation and determine what sort of sampling it is. So for the first one, for the following statements, identify the type of sampling used. And so to determine customer opinion of its boarding policy, Southwest Airlines randomly selects 60 flights and then surveys all passengers on the flights. Does anyone have any clue what form of sampling this may be? Randomly selects 60 flights and then surveys all the passengers. Virtual people, you can chime in too if you'd like.
Cluster?
Let me turn up the volume a little bit. Whoever said that, can you say that again?
Cluster sampling?
This would be cluster. Yes, so this is cluster. The first one is cluster. This is cluster. And if you did form an opinion and think, why is it not simple random or stratified? Here you're randomly selecting groups or clusters. Just think, Southwest Airlines has a ton of flights. They have a whole bunch of flights. You're randomly selecting 60 of those flights. The flights here are not the individuals. The flights are the groups. From all the flights, you're randomly selecting 60. So you're randomly selecting groups. And then you're surveying every passenger in those groups. That is a cluster. That's a cluster sample. You randomly select the groups, and then you survey all the people in those groups. So the first one is in fact cluster. All right, let's see. Let's move on to the second one. 24 Hour Fitness. They do a satisfaction survey. they randomly select 40 club members and ask them about their level of satisfaction. So I guess same question. Which one does this look like?
Stratified?
This wouldn't be stratified.
Simple.
This would be simple. Stratified, there'd be some group involved. There'd be some sort of, I suppose, overlying groups. This would just be simple random for the second one. This is simple random. You're just taking, out of all the people that go to 24-hour fitness, you're just going to choose 40 of them at random. There's no groups involved, so cluster and stratified would instantly be out. And so we move on to simple random. So let's scroll down a little bit to number 3. To determine his DSL internet connection speed, Sean divides up the day into 4 parts: morning, midday, evening, late night. Measures the internet connection speed at 4 randomly selected times during each part of the day.
Stratified.
This one is stratified. So this person, Sean, is dividing the day up into 4 parts. That's 4 groups, which ends up being strata. And then it's within the 4 groups that you are randomly selecting a time. So it's not the groups that are randomized or randomly picked. It's the times within those groups that are being randomly chosen. That's what makes this one stratified. Maybe 4 might be a little bit easier. Let's see. To estimate the percentage of defects in a recent manufacturing batch, a quality control manager at Intel selects every 8th chip, starting with the 3rd chip, until they collect 140 chips. Yeah, that one's systematic. That one's a little bit easier. Anytime you're dealing with 3rd, 8th, 7th, stuff like that, it's probably going to be a systematic way. And this is actually done. I mean, I'd imagine you all know Intel, or any place that really manufactures anything. They have to do things like this. And you don't want to just pick 20 consecutive things. You want to have a spread of it in case you find some sort of, you trace it back to one of the machines that may be malfunctioning. So this is done all the time. This is systematic though. And there was 5 in total. We've gotten 4 of the 5 already. Maybe you might already know what 5 is. A survey regarding download time is administered on the internet by a market research firm to anyone who would like to take it.
Convenience.
What's that? I think I heard.
Convenient?
Yes, it is convenient. Sounds like a very convenient thing. So it's generally known in statistical surveys that people who volunteer to take a survey tend to be more passionate about the thing that is being surveyed than those who do not volunteer. So that would be convenience, which is normally not a very strong form of sampling. Again, people who volunteer to take a survey are going to be more passionate about the topic that the survey is discussing. That's why they call it a convenience survey, or a convenience sampling, which is the worst kind of sampling. So yeah, that concludes really chapter 1 of my notes, really chapter 1 of the book as well. The first homework, so this does encompass everything that's for the first homework that's due tonight. And yeah, if you went ahead and did the problems in the beginning, and the remaining problems you would have are just going to ask you mainly multiple choice about sampling. So they're going to ask you questions just like this, and you have to pick which one it sounds like. Should be pretty straightforward. Does anyone have any questions before I move on to the next chapter, which might be a little bit more interesting? If not, then let's go ahead and move on to the next chapter then. So I'm going to move on to, really should make it say chapter 2. It's not really a unit, it's a chapter. It's not really a unit, it's a chapter. There we go, chapter 2. Summarizing data in tables and graphs. So this is where we start to get our hands on actual data. Here's where we actually get to make some sort of conclusion, because I'm going to involve you all into this category. And as we start going through these things a little bit, I'm going to skip slightly ahead. Out of all of these services you see in this table, just think to yourself right fast which one you use the most. Just start thinking about that. I'll give you maybe a minute as I go through the prerequisite information. Just thinking, which one of these social networking services do you use the most? And we'll come back to this. So hang on to your answer right fast. So this section, this is organizing qualitative data. So remember, in the last chapter, we talked about two types of data, one being quantitative and one being qualitative. Qualitative is the one we're going to focus on here, and qualitative is categorical. This is a category. This is, we talked about before, gender, zip code, phone number, things that are, well, things that can't be added or subtracted. You can't find the average of zip codes. You can't find the average of genders. These are things that are devoid of quantitative or arithmetic, I guess, steps or application. So this could be how many people answer yes or no for something, or yes, no, maybe, or prefer not to say is sometimes a category that, or an option that comes up. And so we have to figure out, all right, if it's not quantitative, which normally, you know, quantitative, we can add and subtract them, we can find the average, we can find the standard deviation. But what about if things are categorical? Really, the only things we can do for categories is count them. And that's exactly what we're going to talk about in this section, and the different means for expressing that quantity for which we obtain. So a frequency distribution, that'll be the first thing we talk about. A little bit of terminology here. A frequency distribution, it lists each category and the number of occurrences. So basically a frequency distribution is how many people are going to choose a certain thing over another. And this is a great segue into the following example that I told you all to think about. So we're going to actually do a qualitative survey right fast for example 1. I'm hoping we get a nice spread of inputs for all of this. So if you're virtual, if you're virtual, hopefully you can see my screen right now. You can type in here and put in whichever one you use most often. So go ahead and type in the one that you use the most often if you're virtual. And all right, let me go back to it. And then I guess physical people, I can just count. So out of all of these, who uses Instagram more than the others? 1, 2, 3. 3. Put that off to the side. Facebook. Yeah, Facebook's for old people, right? Twitter. Got 1. Cool. Snapchat. 1, 2, 3, 4, 5, 6. I thought Snapchat was the one that was dying. Oh well. TikTok. Thought that would get more people. So 0 and 0. What about none? Other none. 1 for me. Okay, cool. So I'm going to compare that with the online people's responses. Okay. So let's see. I'll put this off to the side. So that's Snapchat. I got 2 Snapchats for a grand total of 8. What else do I have? There's a Twitter. 1 Twitter on top of the 1. That's 2 Twitters. Okay, there's 3 Instagrams. Okay. So that's 6, 0 Facebook, 0 TikTok, and I'm the only one who doesn't use it. All right. So that gives us a nice little spread here, and also tells me which people in the virtual group are actually in class. I think that's pretty clever. So this is our count in total. So we have a decent spread here. Sure, no one uses Facebook or TikTok, but we can make this work. And so this would be a frequency distribution out of everyone who participated. So 17 people. This is how your most commonly used social media service, social networking service is distributed. That's it. So we're going to come back to this. We're going to bring up these numbers again. But yeah, that's a frequency distribution. That's it. Pretty simple, right? Cool. Now we're going to move on to relative frequency. Relative frequency, so we can count things all day, but how do we measure that? If I said I went around on Southeastern and was told that 250 people used Facebook the most. Well, 250 is nice, but this quantity doesn't mean anything without some comparison. 250 out of what? Out of how many people? That's a nice number, but how does that compare to the total number of people who were surveyed? And that's when relative frequency comes in. It may look like a funky formula, but you simply just take the number of occurrences that you found for that particular category, and you divide it by the total number of people. So it's almost, it's not really an average, but it's something similar to if you were doing an average in a sense. And that's really what we're going to do down here. We're going to take the frequencies we got before. So I'm going to write all of them down. 602,801. 602,801. And we're going to find the total of all those. I think I said it was 17. So 17 is the total. The relative frequency will tell us the proportion of each one of these. So what percentage of respondents gave that as an answer? So the relative frequency, simply enough, the first one would be 6 divided by 17. And generally, this is represented as its decimal form. You can also think about it as a percent as well, but in terms of the table, they normally use the decimal form. So this is about 0.35. So that's exactly what we'll put here. Facebook, obviously that's 0, because that'll be 0 divided by 17. Twitter's the next one. So 2 divided by 17. You get 0.12. And we just keep going for each one. This would be the relative frequency. The frequency relative to the number of respondents. And we just do this for everyone. 0.47. So that's what we put here. This one's easy. And then finally, I'm the odd man out, so how much does my response contribute to this whole thing? 0.06, or 6%. Now, what happens if we add all of those relative frequencies together? Let's find out. We add all these together. 0.35 plus, well, plus 0, that's going to be 0 still. So plus 0.12 plus 0.47 plus 0.06. And notice we get exactly 1. That's interesting. We get exactly 1. So now instead of saying, if I went out to a colleague and said, I had 6 of my students say they prefer using Instagram, well, hopefully my colleague would say, well, out of how many? And that's where the relative frequency comes into play. It tells us that 35% of students in my class who actually bothered to respond, provided that they enjoy Instagram more. So I suppose the next question is, or in other words, 35%. And then a question, should the relative frequencies always add up to 1? Was that a coincidence or was that not? Does anyone have any idea? The relative frequency. Say that again, I'm sorry. It is always going to be divided by itself. Ultimately, so, yeah, so you are right. And let me just refine what you're saying a little bit more. So it will always be 1. So this is true. And the reason why it's true, well, I think the most simplistic way is that every respondent has to belong to some category. So when you add all of these, so all of these relative frequencies are just fractions. So notice 6 people was in that numerator, 2 people were here, 8 people and 1 people, or 1 person. When you add fractions together, you add up the numerators and you keep the denominator, provided the denominator is the same. The numerators just represent the frequency. You add up all the people that participated, you get the total number of participants. So then, in a roundabout way, you divide it by itself, and the quotient will be 1. Because every respondent has to belong to a category. That's why. Plus, if they did not add up to be 1, then that would imply that there's another category out there. But I took care of that by putting other/none. Every respondent must belong to a category. Cool. So hopefully that's pretty straightforward so far. That's something we can do for qualitative or categorical data. We just count them up, figure out what that proportion is relative to everybody else. Any questions before we move on? If not, move on to something that may be familiar, a bar graph. Maybe you've all seen a bar graph, and if not, we'll talk about it here. Bar graph is a collection of parallel bars, and the lengths are indicative or proportional to the number of things we counted in each category, in other words. So the more people that said they like something, or that's a category they choose, the bar gets a little bit higher. So mainly it's best to define a bar graph by looking at a bar graph. And we can do bar graphs for the frequency, which was counting the number, and we can do a bar graph for the relative frequency, which was the percentage that each category was in relation to the total. So let's go down here to the frequency bar graph. We'll make a frequency bar graph for each one of these categories. So was it? I think it was 6. Oops. Just to remind myself, 602,801. I believe that was the spread here. And these are not going to be very large bars. In general, you want the bars to sort of fill up the graph, but we're just kind of predicting here. So, of course, 6 would be right in the middle here. So, of course, we would want the bar to come up to 6. And then Facebook, there's nothing to put. So, flat line. Twitter is 2. So this one's going to be a very small bar. Snapchat was 8. Go ahead and fill that in. TikTok was 0. And then none, so just 1. So in general, if you used technology to generate this bar, it would have 8 as the highest frequency value. Normally you would want the bars to fill in the graph. Like I said, zoom in a little bit better. Makes it easier to read. But this should be fine for our intents and purposes. And so now writing this as a relative frequency bar graph. So this is where, so notice the y-axis is not labeled because I had no idea what to expect in terms of the distributions. So let's figure out 0.35, 0.12. So just to remind myself, that's 0.12. For the other 3, 0.06. Oh, wait, I skipped one. 0.47, 0.06. 0.47, 0.06. And so now, so the relative frequency are those decimals. And so now I need to go ahead and write these up, but I need a y-axis. I need some scale. So let's see, that's 1, 2, 3, 4, 5. I'm guessing 0.5 would be a good one here. 0.5 divided by 5. So let's see, 0.1, 0.2, 0.3, 0.4. Again, technology does this for you. I just didn't know what to expect in terms of the spread. But yeah, if you typed all this information into a computer and told it to do all of this for you, it would generate those y-axis margins for you, markers. And so from here, it's the same thing, except the bars do not indicate their frequency count, it's their relative frequency count. So Instagram was 0.35. It might be hard to see here, but the table, we figured it out already. So 0.35 will be right in the middle here. And fill this in. Facebook 0, so no bar. Twitter is 0.12, so a little bit more than 1. I'll say right about here, or yeah, a little bit more than 0.1. 0.47, this one's going to be much larger than the rest. Almost at 0.5. TikTok 0. and then 0.06. So maybe a little bit close to 0.1, but not, maybe that's too close, but it's fine. Does anyone notice a somewhat of a similarity between these two graphs? It looks like the exact same graph in essence. I mean, notice that the tallest one is still Snapchat, and then the next one's Instagram. Basically, in more refined terms, the scaling of the bars is the exact same. Whether it's something that talks about frequency or relative frequency, the bars, in terms of how they compare to the other bars, that comparison will be the exact same. So that's something to keep in mind. This is just two different ways of reading the same information. Sometimes people like to look at the frequency bar graph. They just like to know the numbers. Or sometimes if there's a lot of numbers, it's just better for them to see the relative frequency bar graph. So they can see, all right, which percentage of people pick this? I don't care how many people, I just care about the percentage. So this is how bar graphs help us with interpreting not only the number of people selected a certain category, but the percentage of people that selected a certain category. So how does this feel so far? Pretty straightforward. And then there's a, I didn't really look up the spell or how to pronunciate this, a Pareto chart. It may be pronounced some other way, but I'm going to say it that way for now. Pareto chart. Basically, it's the bar graph where you put the boxes in decreasing order. So you put the highest one on the left. In fact, the best way to see this is just a completely different example, but notice the bar graphs, their heights just decrease. So if you hear Pareto chart, however you pronounce it, that's all it means. It's just bar graphs in which the heights of the boxes decrease. And so it took me a while to come up with this example. I think this is a pretty good example. Every year, Southeastern publishes a semester registration report. And so I went ahead and so generally this is helpful if, you know, Southeastern gets a lot of money, as you would imagine. So they want to figure out, all right, how much money do we give to this college and this college and that college? Because, as you know, Southeastern University is broken up into smaller colleges. So how much money do we give this college, this one, and that one? Well, I also want to know how many people are in each college, so we know, at least have an idea of what percentage of funding to give each department. If there's a department that has, you know, you see education as the smallest one over here, you don't want to give them 25% of your budget because they nowhere come close to that percentage. But and just to put some perspective into play, this is nursing, health sciences. This one's arts, humanities, sciences, and that's science and technology. If you're interested in said article, I did link it here. And notice this is using exact stuff we're talking about. This stuff isn't too crazy. They use bars that are bar graphs and other sorts of statistics that, and we'll talk about this one next actually, but that's where I got these numbers from. As you can see, nursing and health sciences for fall 2020 was 25% of our majors. Undecided, probably 0.18. So in other words, here's a Pareto frequency distribution. Notice the relative frequencies. This isn't telling us that 0.25 people are nursing health science majors. That doesn't make any sense. This represents the percentage or the proportion. 25%, I think it's legitimately 25.17, if I remember correctly, but that tells us the relative frequency. And then out of 14,461, so there is a question to this problem. if I told you that there's 14,461 people relative to the fall 2020 semester, approximately how many of these are nursing health science majors? So all I see here is a relative frequency of 0.25. How do I figure out the number of students that are nursing health science majors? It helps. Let's see if I can put all this in the same screen. There we go. Oops. So there's 14,461 students. How many of them are nursing health science majors? If we know that they comprise roughly 25% of the student body. Anyone? So how so? So to figure out 25% of a number, we multiply. We're going to multiply here. So nursing health sciences is, we'll say, about 25%. So we want to figure out 25% of the 14,464. So times, not 25%, but 0.25. That's when the proportion comes into play. So let's figure out how many nursing health science majors we have at the school relative to last semester. And of course, we tend to get decimals with these things, but we're talking about people. So I'm going to round this to 3,615. So about that many students are nursing health science majors. Again, this may not be a perfect number. We did kind of, the bar graph only offers us so much information. It doesn't tell us the exact percentage, and we sort of, I always mix up interpolate versus extrapolate. I can't remember which one it is here, but we sort of just guessed the percentage in essence, and it looked really close to 25. There's no way we were supposed to know that it's 25.16. So this is good enough. And there is a homework question that asks you about this, so that's why I wanted to make this clear. Does anyone have any questions before we move on to another type of graph? Okay, so there's also a side-by-side bar graph. And as you would imagine, well, we're dealing with bar graphs again, but side-by-side allows us to take two distinct bar graphs that may have very much connected information and merge them together into one graph. Or in other words, we may have a bar graph, but within the bar graph, we want to explore how specific people within those correspond. And so example 5 shows a good example of this. I actually got this straight from that same report I brought up before. So that exact report shows a side-by-side bar graph. And yeah, men and women are generally, that's probably the most popular characteristic that is used. Normally, they like to do this as well for when they make studies about improving diversity on campuses. They like to split this up by the proportion of a particular group relative to that major. And this is done all the time. In fact, not only does it help you compare between how, say, females are distributed among majors, but it also tells you that, well, women are 100%, well, maybe I shouldn't use that in this class, but women are a lot more likely to go to college than men. And that's very evident here as women just comfortably dominate the numbers game in virtually every category, the exception of barely being edged out by men in business and science and technology. But in general, women are more likely to go to college than men. And this graph shows that, at least relative to Southeastern. And so it gives us, instead of looking at two separate bar graphs, which may even be scaled differently, this allows everything to be scaled the same way, everything put onto the same graph, and we can definitely see. I know stuff like this is used. I know there's a big push to increase the number of women in science and technology, and they like to look at numbers like this or comparisons like this and think, how can we encourage more women to take part in science and technology? How do we advertise certain regions? And they'll do this for the various regions from which people come from and figure out how to advertise in that regard. So things like this are used all the time. We're already in chapter 2 and we're looking at things that people at Southeastern, they pull all this stuff together and they do that to make conclusions and future, future resolutions about you all, about us, about the student body. And then after I'm done with all this, I kind of wanted to show another helpful collection of surveys and whatnot. But in other words, yeah, this is a very helpful side-by-side graph, and there's, of course, many others that can represent a plethora of things. And using this, we can go ahead and figure out the relative frequency distributions. And so you might think, well, how do we figure out the relative frequency distributions? We need to take the number of people and divide that by the total number of people. But are we dividing it by the total number of people or by the number within that specific category? For example, if we want to figure out, what's the very first one? It's men in, that's arts and health sciences. So men in art, health sciences, or humanities and social sciences. Oops. Arts, humanities, and social sciences. Well, it seems like the men are here. Do we divide that by the total number of participants or by just the total number of men? We're going to use the total number of men. It's going to be the total number of men. And I did write them at the bottom here, just so you don't have to go add them all up. 9,262 female students and 5,198 male students. That's why I put that down here. So the number of men was 1040. Divide that by the total number of men or male students, 5,198. And so let's see what decimal we get from that. 1040 divided by 5198. So about 20%. A solid 20%, or 0.2. And really, we would do this with every category. So 20% of our male students, our male student body, are majoring in arts, humanities, and social sciences. And we can do that for every other category. I think the next one is 1098. I'll write out a few more of these just for convenience. So this one should be very close. 1098, 0.21. 1. And when they say Center for Student Excellence, that means undecided. That's their fancy way of saying if you're undecided. So let's see. So we have 990 undecided men. 5198. 0.19. 0.19. And we can figure out the rest of them pretty quickly. Education, very much lacking in terms of male demographic. 183. 0.0, let's say 4. Next one, 677. 0.13. And then 1,196. Zero point 2. And we can do the same thing for women. One 1805. But we have to divide by a new number though, because there's a lot more women. 9,262 females. So there's a new number we have to divide by. So 0.19. And we just keep going for each one. Next one seems to be 1059. 9262. $1,533 for the next one. One 7. And we can keep going. 1003. 0.11. And then, as you can tell, women dominate nursing and health sciences. 2,961 divided by that total was 9,262 for a whopping 32% of the female body that goes into nursing and health sciences relative to fall 2020, and science and technology, 877. And when you add up those columns, you should either get 1 or a number that's very close to 1. The reason why it may be very close is because we rounded a lot. We may have lost precision by 1/100th of a decimal place. Does anyone have any questions about these sorts of graphs or qualitative analysis in any regard?
No, sir.
No. Okay. I wanted to show on Southeastern's website, they conduct these surveys fairly often, which is some of the stuff I was looking at in order to get some inspiration for some of these problems. You might have already taken an entering freshman survey. Let's look at the one from when I started college. Actually, oops, that's a year off. So notice for incoming freshmen 2010 to 2011, this was published in 2013. So what's the weight? What are they taking their time for? They want to see how you're doing. They want to see how your answers scale after a while. And notice just by reading this, it starts off fairly technical. Talks about orientation. So this is something we've all had to take. I was a student here, so I had to take it probably, that was 10 years ago. I can't remember taking it, but we've all had to take this at some point. And notice they use little n, which is something we use when talking about simple random sampling. They tell various spreads of information. This is to understand what the respondents are like, what you all are like, in order to try to accommodate things, because Southeastern's a business. They want to try and impress you as best as possible, try to keep you around, and then want to figure out who you are as well, to figure out how they can also advertise the future students who they predict would probably fall into this spread here. So there's 86% traditional students. You can see a bunch of various numbers this way. They also do stuff like this to predict parking. In fact, the one I was looking at. Okay, here it is. So this table and this spread of information, notice that 34% of people commute more than 30 miles away. Notice they took that percentage based off of the respondents relative to the incoming freshman group, and they say from that sample, this supports the notion that there's a large commuter population. Notice how these things that we're talking about, these very simple introductory things, slowly play a part into things that are used, well, on a day-by-day basis by many people at Southeastern. There's people who get paid big money to bring these statistics together and make, this is helpful for, say, if you need to increase freshman parking and you want to have an idea of what your incoming freshman class is like in terms of commuting and whatnot, or about housing as well. These are all ideas that are all based off of statistics. So I thought this was very interesting. There's various spreads, no influence to major influence. These are types of categorical or qualitative measures. And then there's some that will be quantitative, which we will talk about Wednesday in class. But I think these are all, I suppose if you were curious about the applications of these things, Southeastern does have these collections of information. And I believe what I used, I'm trying to remember where I found the one that I used for this class. I'm probably not going to find it. I don't have anything else to talk about. I'm going to just wrap up class right there. Have a good day.